and the video was so long because you kept having random conversations and it was making me laugh.
Just wait till you get to the one that I talk about going on Dancing with the Stars.
And I just heard like Peyton and like Josh Giles in the background. I was just like, huh. And like your iPad was geeking out, like it wasn't working right.
What's your
That was one of the digital videos. Yeah. All right, 3.3 graph systems of linear inequalities. So basically, we're going to be graphing pretty much anywhere from 2 to 4 inequalities on a graph, and then we're showing where the solution is. The solution is where all of the shading overlaps. So, number 4. X is greater than -1, X is less than 3. So a few things that I'll be looking for here is that you still are doing it correctly if it's solid or dotted, and then obviously the direction of the shading is going to matter. So,
oh, it's this.
okay. So I'm going to set this up. All right, so X is greater than -1. That's dotted. It's on X is -1, going straight up and down.
I just don't like having to do the graph.
And X is greater than, so that means I'm shading where X is bigger, so I'm shading on the right. If you want to use colors and like highlighters so that you can see it better, obviously I'm fine with that. Or colored pencils, I have some stuff somewhere. I have to find them, but I do have some if you need them. And then X is less than 3. Well, at 3, I have a dotted line going up and down as well. And this one is less than, so it shades on the left. So the part where the colors mix is the solution. So we point to it and show that that's where the solution is. Now, when I get to the ones that have 3 and 4 things, I try to use like lighter colors to shade with, just because it gets to be a lot going on. I would strongly encourage that you use colors when you do this, because if you're using pencils, it's going to be confusing. Just like a regular pencil, it's going to be confusing as to where the overlap is. Like add some highlighter, some colored pencil, something. I mean, if you want to do your line is like in pencil, that's fine, but just watch your shading so that you don't get confused. All right, so that one relatively easy. Number 10. -x is greater than or equal to y, and -x plus y is greater than or equal to -5. So I want to get the y's on the left. So all I need to do with this top equation is to swap it and say y is less than or equal to -x. I literally just took the whole thing and flipped it over. The other equation, I need to add x to the right, so y is greater than or equal to positive x, not negative x, -5. So what's going to be true about both of these? Like,
solid line.
Yeah, they're going to be solid. So I'm going to set up a graph here. Whoa. All right, so the first one has an intercept of 0. You're going to make it.
Hopefully.
Down 1, right 1, down 1, right 1, or up 1, back 1, either way. Solid line. All right, now which direction does this one shade?
Down.
Yep, below. So this one's going to shade down here. All right, and this other one has an intercept of -5. Positive slope, up 1, right 1, up 1, right 1. And this one's also solid. Which direction does this one shade? Yep. So this one's up here. Now, the thing to notice is I don't just shade right here and stop. It continues to shade over here. So I'm looking that you shaded your entire graph correctly. This area over here that's basically turned purple is my solution. So you always want to label your solution, show where it is, because otherwise it doesn't really tell me that you know the solution. Now, if you wanted to check this, okay, if you're like, I don't know if I'm shading correctly or not, take a point from in here. So say -1, 0, for example, because that's in this region, and plug it in and see what happens. So 0 is less than or equal to negative times a negative is a positive. So 0 is less than 1. Well, that works, so it's good on that one. Now Addie's dying.
Jonah, why'd you give it to me?
Now I'll check another one, or check the second one, and we'll show that we've done it correctly. So I've got 0 is greater than or equal to -1 minus 5, so -6. 0 is greater than or equal to -6. That's true, so I know that my solution is good. Okay, you can either mentally check it, or you can write it down and check it, or you can choose not to check it and really hope that you shaded correctly. Up to you,
Flowers
but.
put grades in, by the way. Yes.
Oh, I was like, y'all don't have her. Okay. So when there's just 2, not so bad. Probably not the end of the world if you were to just be using a pencil. However, the farther down we go, they get a little crazier. 18, x is greater than or equal to -8. Y is less than or equal to -1. And y is less than -2x minus 4.
What's the max amount that they give you?
For our book 4.
I finally have all these.
It's a lot of lines. They just give you everything.
My speech grade is an 89.8. Hanging on. It's still an
Better hope she doesn't add a bunch of grades that are lower than that before
She
Friday.
just put grades in because it was
Okay.
at 89.2.
Wow, it went up.
0.5.
All right, I know x has got to go all the way over to -8, so I'm going to make my graph excessively large on the left side.
50.9.
Oh, 0.6.
0.2. I said 0.6 to begin with.
I like this.
Going to
Why is my line not fixing itself?
Excuse me. What? Excuse me.
Me too.
All right, so first one. And a lot of times if I'm using like different colors like this, I'm going to show what I'm doing so that I don't get confused on like where my graph is or something. All right, so this first one, x is greater than or equal to -8. That means at -8, I have a solid line because it's greater than or equal to going up and down. Which direction does this one shade? Yep, to the right, because that's where the values are greater than. All right, on the y is less than or equal to -1. I have a straight line going across down here. Now, where does this one shade?
Down.
Yep. Keep pushing the wrong button. All right, so this one is shaded down here.
So satisfying to do.
What? Not so.
All right, then the last one, yellow might be a poor choice. We'll see. At -4.
No, I colored in the wrong color.
Yep, can't read that. Let me choose a different color.
Like green.
Let me try a dark green for the point. Nope, that's the wrong thing.
There we go.
There we go. Okay. All right, now this has a negative slope, but instead of making my graph even larger, I'm going to go up to back 1. Up to back 1. Now, this is a dotted line. I definitely should have chosen a darker color or done this one first, but that's okay. All right, now where does this one shade? On
Also
down here or up here?
Down.
Yep, down over here. So this one's getting shaded over here. So this area right here, where everything is colored in. I'm gonna use purple to do this. Nope, this one. So this area down in here is my solution.
Game. What? It's a game.
I'll just stuff the one on this crap.
Is there an issue?
These are what mine used to look like before I had my iPad. All right, one more that has 4 so that you can see what this would look like. Or, well, any questions about these ones before I go on to one that's even harder?
I don't even want to talk about what I just did. Where did I put this?
You can just sit right there. And don't forget your calculator. I don't know where you left it. Oh, it's in your pocket. All right. 24. X plus y is less than 5. X plus y is greater than negative 5. X minus y is less than 4. And x minus y is greater than negative 2.
Oh, what is this?
Just like we did last year, you know, like the shading up above the lines and stuff.
Oh,
It's coloring.
yay.
One of the few times in math that you get to color. Although we do color at holidays because I have math coloring sheets that go with each holiday.
So Thanksgiving, what would color a turkey?
Before the Great Pumpkin Day, we will color
Great pumpkin day.
October 31st.
Harvest Fest.
Yeah.
It's Friday.
Because we're not allowed to celebrate the other day.
Why?
Wait.
Because it's sacrilegious.
Because it has a bad connotation. It's not just a day of getting candy. So,
Baltic paganism created a keep away evil spirits.
but some of my they're like little calculators that are like going trick or treating and
Oh.
they have like little candy. They're really, oh yeah, they're fun. Anyways, I hang them up in my classroom.
I feel like I remember seeing
So we'll probably do that after whenever your next quiz is.
That's
Thursday, Friday.
math.
After Friday, we'll probably color
Not using my
so that I can hang them up. Okay.
that. What did we use to decorate for our thingy thing? For the chili cook-off?
I'm just staying Friday after school. I'm not going anywhere.
Like, what are we using? Like,
Matthew's got it all under control apparently. I bought the backdrop, but he's got all the Christmas stuff.
Oh,
And Jack's parents are bringing the chair for the Grinches to sit in.
Okay.
It's a red chair.
Oh, I want to get a bag. Like a big red bag.
All right. So to do this problem, I first need to get y by itself in each of the equations. So I'm going to start out with green because that way it won't get hidden in there. All right, so y is less than negative x plus 5. I'm going to just graph these one by one because that way I can just stay with the color that I'm doing. Okay, so this has an intercept at 5. Slope of negative 1. Is this solid or dotted?
Dotted.
Dotted. All right, now which direction am I shading? Below. So that's everything down here. This next one is going to be y is greater than negative x minus 5. So I have a intercept at negative 5. Has a negative slope, but instead of making my graph bigger, I'm going to go up 1, back 1. Is this solid or dotted? Dotted.
I like dotted lines better.
I don't because it's not one smooth thing to write.
Me too.
All right, which way does this one shade? Yep, shade above, so that's up here. Alright, over here, I'm going to end up with negative y is less than negative x plus 4. When I divide by a negative, what happens?
Side flips.
Flips it, so this is going to be y is greater than x minus 4. So I have an intercept at negative 4. A positive slope, so up 1, right 1. Dotted as well. And where's this one shaded?
Wow.
No.
Wait,
Y is greater than x
Oh,
minus 4.
I'm sorry, I was still looking at the other one.
hey, I just got it.
So above,
Oopsie.
Oh wow, it's so dark.
It's purple.
okay. Alright, last one. Again, I've got to move this around, so negative, whoa, not that, okay. What is happening? Go back up here. Okay. So I've got negative y is greater than negative x minus 2. Divide by the negative, y is less than x plus 2. So at 2, I have a point. Up 1, right 1, or down 1, back 1. This is also dotted.
I can barely see it.
Yeah, I can barely even see any of it.
If you can't see the dotted
Shade down.
line good enough, do you want us to like write an arrow to the line and say it's dotted?
Well, that's when you draw a solid line.
Well, if it's really hard, yeah, you can point to it and be like
This is dotted.
dotted. I mean, I've never had an issue being able to tell. It should be easy enough for me to see what it is. I mean, I'm mainly looking for the solution. It's really like if you don't have 4 lines, obviously I'd be taking off if you put them in the totally wrong spot, but I should be able to see roughly enough. I mean, don't use like the darkest colors possible. I would use like, orange, yellow, green, things like that when you're shading it so that it's easier to see. Don't use like navy and black and dark purple. Obviously it's going to be difficult. All right, so then this one was down. All right, so the solution is this entire middle area. I'm just circling it so you can see it. So that is my solution in there.
I'm so cooked.
I also don't normally give you 4 on a quiz or a test. I normally give you like 2 or 3 because
Yay.
it just gets to be a lot.
It does look like arrow.
All right, any questions on this? Pretty easy.
That's pretty easy.
Homework, that's
So hard.
All right, problems 5, 13, 19,
Oh my gosh.
25.
No math.
This graph paper, even if there's like one little thing on it, it's 18.
Yeah.
Does anyone have it?